Hi everyone, welcome to today's webinar, Go Beyond Color, Leveraging Color and Appearance for Product Design. Presenting today is Thomas Meeker, a 3D solution architect at X-Rite. I'm Robert Grotans, the Global Digital Learning Manager, and I'll be moderating today's webinar. I just want to go over a couple of things before we get started. Due to the number of people that are attending today's webinar, we will keep everyone muted. If you have any questions during today's presentation, please use the questions function on the GoToWebinar panel, and we'll have some time at the very end of this webinar to answer a few of your questions. Finally, this webinar will be recorded, and we will follow up with an email after this webinar with a link to the recording so that you can watch it again. So with that, I will turn it over to Thomas to get things started.
Hello, welcome everybody. As Robert mentioned, my name is Thomas Meeker, 3D solution architect with X-Rite Pantone. And today we're going to be talking about going beyond color, leveraging color and appearance for product design. With that, I'll go to the next slide. All right, so many of you have most likely heard of X-Rite. Even more of you have probably heard of Pantone. But X-Rite and Pantone, we consider ourselves the art and science of color, taking you from inspiration through production and digitizing color and appearance. The images that you see are 3D renderings utilizing our appearance data from our solutions at X-Rite. So with that, go on to the next one. So color and appearance, the color and appearance challenge. So we have the different stages of the product design process. We have in the first steps, the design and specification. So these are the brands, whether they have their own branding tool set or they're working on a new collection. And then those that are specifying too, working within the same constraints or limits of the color and appearance palette. So we are talking about the inspiration. So what are the trend colors in forecasting, defining the determination of color targets, but then also we have on the other side, the pre-production and the production. So the manufacturers and producers. So this group is typically working separately from the brand design and specification. But what we're trying to do is help link all of those different stages of the design process. So one of the ways that we can do this is through the communication of appearance and color data. We have been able to do this very much so with color data by using spectral data, things like that. But what we're trying to do now is actually share more information to reduce the amount of design, iterations, prototypes, things like that by working in a new digital workflow. So what are the things that, what are the rewards of advancing your current color program? So things like improving the time to market. We can work faster. We've got a couple of metrics about being 4 times faster, which improves the cycles and minimizes the time required to match colors across numerous substrates. This is enabled by working digitally. So aligning the physical samples or physical prototypes that we're using and having the confidence that the digital counterpart to that is looking correct as well. We're also going to be able to achieve some of the organization's sustainability goals, having to ask for less prototypes, ask for less physical samples. Those types of things are going to allow us to limit the amount of physical materials and the waste that's created from that. Optimize spend. So by reducing rework and having to do less physical iterations, we can add to profitability. So with so many places for color and appearance to go wrong, it can be hard to know how to get it right. So that's where X-Rite Pantone comes in to help with that process. So what are the benefits of appearance measurement? So this idea of going beyond color. Appearance dictates how color is rendered. So with the image on the right, what you see is I have specified a color. I may have picked this from a Pantone library. I may have chosen this from some other inspiration mood board or something like that. But what I'm doing is taking that color and then applying it to all these different types of materials or substrates. You'll see there's a perforated leather. We've got more of like a velvet, a straight leather, and then this textile in the back. Well, we can see very clearly that depending on the type of material, this is looking, each material, the color is looking just a little bit different. So we can't depend on just color in our specification stage. We really need to understand the full appearance of a material. So what is appearance? When we talk about appearance, we're talking about, of course, color, but we're also talking about things like gloss, texture, translucency, transparency, complex fabrics. So think highly reflective, or maybe they have some sort of sparkle, or yeah, some sort of appearance characteristic that's really hard to communicate without having some form of doing so. So appearance solutions, what are we talking about? What are the ways that we're solving the problem of going beyond color to be able to communicate this across the different parts of the manufacturing and design process? So appearance impacts our overall color, which we've talked about. So it's crucial to account for attributes like gloss and these shimmer effects, which we mentioned. And the materials that we're talking about, more specific to product design, are paints, plastics, metals, fabrics, and certain kinds of meshes. So materials that have some opacity to them, whether it be like a mesh, or if it's simply just like a sheer satin or something like that. Those things are going to change how the overall appearance is seen. So when we're communicating this vision, we have these tools that we can now use. We have tools that allow for virtual material scanning. So that's the process of actually measuring full appearance. We have a way of communicating that appearance. And in the case of X-Rite, we have a solution called the AXF, which is our appearance exchange format. This is a file that contains not just the color, but also all of the other characteristics about appearance. And this is all organized and connects to our solutions so that we can better create a library of all of our materials, whether that be by catalog, standard materials that you use in all of your designs, things like that. This is a way of organizing that data, being able to quickly look at the appearance, and also save all of that information. So appearance capture, what are we using to do appearance capture? How do we measure and build that virtual library? So one way is taking color library information that you may already have. So if you've got CXFs, which is our color exchange format, and you've already built a library, well, that data can be reused inside of the Pantora software. So think about, if you've got a plastics collection and you want to bring that information in, I don't want to have to remeasure the color of all of those samples. We can bring in some of that information with the CXF file. Then we have some of our instruments. So down on the bottom left, you're seeing 3 instruments that are perhaps instruments you're already using for different color quality control purposes or simply color specification purposes. We have on the left the MetaView, which is a 045 degree device, spectrophotometer. In the middle is our handheld multi-angle MAT12. And then on the right-hand side is our benchtop spherical geometry spectrophotometer. And we see on the top the AXF, that is the file format that we're creating, that appearance exchange format. Some of the benefits right within the software and what you get with the AXF, we can actually attach quality control information inside the AXF. So it's gone through an approval process, so-and-so has signed off on it. There's metadata and other information that can also be a part of this appearance exchange format. It's not simply color and not simply just those appearance characteristics, but actually extra data through metadata that we can attach. We also have our own rendering engine inside of Pantora. So this gives us the ability to visualize our virtual materials in a 3D space. We have different ways of bringing together lighting and objects, and then the materials or the AXFs that you bring into the software. It's all customizable. We can also, and this is what's coming later this year, is actually begin to validate or QC our appearance information. So if you've worked with any of our iColor, IQC type softwares and you're used to doing quality control across samples, physical samples, this will work quite similar in that we are taking measurements of our physical and running a quality control of our virtual sample, just adding to that confidence that we're using a material that we can trust when we hand it over to our designers. So I ran a case study here, and we chose this shoe, and what we used were our MAT12 instrument, which you'll see in a moment, to do the measurements of all of those materials on the shoe. So we did actually buy one of these shoes, and then we took our instrument and measured each material separately. But to be able to visualize this, I went on Turbo Squid, who's one of our great partners, found a model close to the design, not exact, but was able to grab the shoe, then take that wireframe of the shoe and bring that into 3D modeling software to then add the materials and render the shoe with those materials. Like I mentioned before, the instrument we use is the MAT12. This is an instrument that is often used in the measurement of effect pigments. Think car paints for the automotive industry. But with this instrument, by combining both the spectral filter wheels, all of the hardware that's used for measuring color and getting spectral data, and then we're also using a camera embedded to do the measurements of things like the gloss and things like texture. So with this instrument, we can actually measure many types of materials. So with that, we went ahead and we measured the physical sample. And then what you see on the bottom are all of the thumbnails of those measured virtual materials. And then voila, we have our final 3D rendering of our shoe. So this is a 3D rendering. It was done in Autodesk Bread, which is a Autodesk product, and rendered it so that we could actually see how this looked. And it looked great. So if we go back to the photo and then we go to the rendering, we can really have that confidence. So that was our case study. And then here I've got just a quick animation that does some close-ups of the different materials. So you can see the shoelace material, how well it was measured. And this type of measurement is done very quickly. We're talking a minute or two to measure and post-process the data. All right. Let's go to the next one. So next we're going to watch a demo of how easy it is to use the MAT12 in Pantora and the new benefits of using a device that we've already had in our portfolio, but using it for more than just color going into appearance.
All right, so I've opened up the Pantora software, and underneath the Connect tab, we're going to have a list of devices that we're connected to. So in this case, we're going to use the MAT12. It'll give the serial number. We can also check that it's calibrated. In this case, it is. So the next step is choosing what type of job we want to do, naming it, and then telling it where we want the final file to go. What we're doing is we're creating an AXF file, which is an X-Rite file for appearance, and that we call the appearance exchange format. And we're going to add it to our material tray when it's completed. We also can add metadata, so just know that this is another option if you want to add things like the vendor and the catalog or whatever other items you want to add, that is possible. So for the measurement program, we have 3 different types of materials we can measure with the MAT12. We have what's called an NEBRDF, so that is homogeneous materials, think like single color plastics and paints and things like that without texture. We can also do car paints, and we can do textured materials. So this one says NESVBRDF, and it applies to our textured materials. You'll also see that there is help over here. So if I'm clicking, I want to know more about what I'm choosing. We do have help, comments, as well as sample images. So the first one I'm going to do is a car paint. So in this case, I'm going to measure this car paint here. And so we need to basically tell the program what are we looking for. So in this case, we have a clear coat, we have effect pigments, and a number of other options that we can change to better realize or measure the material. So the last piece here has to do with, do we want measurement data? Well, yes, in most cases, you'll probably want the measurement data. We also can choose our color format. You have 2 options, sRGB and spectral. And again, in most cases, you're going to use spectral because the rendering program will do the conversion to sRGB for you, and but you'll be able to store spectral data as well inside of the final file. So for this one, I'm going to place the material under the device. You'll notice there's a preview here. I'm going to capture. And in the measurement process, you'll notice that there's a summary up here. This is what we've added into or told the program what to measure. So for this one, you can see metadata 1 entry. So after I finish the first one, you'll see there's a second ability to capture another one with the car paint. This is great if you want to have multiple measurements, multiple spectral measurements inside of the file. But for this one, we're just going to use 1. So I click Finish. I jump over here, and there it is. It showed up in my material tray. So I'm going to jump over to our viewer, place the material on our blob object, And you can see that we are now looking at this inside of our render engine that we have right inside the Pantora software. For a car paint, I may want to use something like a point light, so I can move the light around to better see things like color flop and also affect pigments like flake. All right, so I'm going to jump back over to our Connect tab, and this time we're going to do a different type of measurement. We're going to do the textured measurement. We're going to rename it, click Next, move up to the measurement program, choose the textured or any SVBRDF, and I'm going to measure this plastic. So you'll notice there's a couple of different grains, a larger grain and smaller grain. So I am going to measure the larger grain. And you'll see we get another preview here. I'm going to click Capture. And while that's running, I've already pre-ran some of these materials. So let's take a look at some of the materials that were already measured with the MAT12. So going first to our plastic, here's the larger grain on this one. And here's the smaller grain version. So I did this red leather here. We also did just a powder coated gold material. And lastly, a more textured basket weave material.
All right, so yeah, it's always fun watching yourself on a video, but I hope that was helpful in understanding how quick the process is, the quality of the measurements, like what you actually get with a quick and very detailed measurement of appearance, going beyond just the color, but a full appearance measurement, which can be utilized in the design process, whether that be your 3D rendering program or inside of our Pantora software itself. So here's just another rendering of that lovely shoe. It also is using our color checker and a virtual version of our SPLQC light booth. So we're running a D65 diffuse light as the lighting for this rendering. So this list talks about the software platforms that accept our AXF file. So if you're interested in footwear, you'd want to look at the bottom left. You may in footwear also be using like a KeyShot or maybe one of the gaming engines or some of the Adobe products. And then all of the Autodesk products upper right. And then a few other automotive. We are great partners at Dassault and other partners that we have in that space. So the file format is supported in a large number of the programs that you're probably using already. So thank you very much for joining today. This was a quick webinar. I hope it was helpful, and I hope to talk to you more. You'll see my email address to reach out to me. Like Robert mentioned, it will also be available at as a link for the video. And if there are any questions, we'll open it up. I know we just have a couple of minutes here, but yeah, be happy to answer any questions. And also, just one last thing, we are running a promotion for training for appearance, whether that be our solutions or just training on how to move to appearance. We can also work with you on that. So just wanted to mention that we are discounting the training for that to help people in their journey to move towards 3D.
Thank you, Thomas. Yes, we do have time for just a couple of questions. Before I turn it over to questions, I do want to pop up a quick polling question. If you'd like to learn more or talk to someone to get more information, please feel free to answer this question and we would be happy to reach out to you. Would be happy to give you a demo or provide you with some more information. And while you answer that, I will see what types of questions we have here. Can it handle translucent materials?
Great question. So the MAT12 that I just talked about cannot right now, but the other device that I talked about, our benchtop spectrophotometer, the spherical one, that one can do translucent materials. So we actually get transmission volumetric for volumetric materials.
If the virtual materials contain a pattern, are they automatically seamless, or how do you go about editing those types of materials?
Another great question. Yeah, so if they have a pattern, we do have tools within our Pantora software to make them seamless. There are some limitations depending on the size, but we do have tools to help you with that process.
What is the best approach to scan plastic materials and get the correct color in sRGB on screen?
Excellent. Yeah, so we actually have multiple devices that can do that. So the three that I mentioned at the beginning, the MetaView, the MAT12, and the spherical device, the benchtop device, can all do plastics very, very well. It depends on if they're textured. If they're textured, we point you towards the MAT12. So it really comes down to what the plastics, what the characteristics of the plastics are, and then we would recommend the appropriate solution for that. So it may be a combination, it may just be a single instrument, but we can actually use data from multiple instruments and compile that into the AXF format. So yeah, would be very interested to talk to you more about that. Good question.
I see a lot of questions coming in here, but we have time for one more question here today, but we'll definitely follow up with you. For more three-dimensional materials like weaves and heavy textures, are you able to provide a bump height so it doesn't come across so flat?
Yes, we can. So with our benchtop does not allow for texture. What we use is a camera inside the MAT12 and the MetaView to do the texture, camera in different lighting angles. So there are benefits to each one. So it depends on the type of material and the variability or distance of the texture itself, right? So if it's like a basket weave, depends on how thick that basket weave is, but we can certainly do that. For ones that may have even a larger one, we do have another solution, our TAC7, that we run with that we can make available through a scan service too. So just depends on what the material is and finding the right solution. But yeah, we can create a normal map for the bump, and then in some cases also create a displacement map or height map. Great question.
Awesome. That was the last question we have time for. So this will mark the end of our webinar. Again, if we didn't get to your question, we will follow up with you and get you an answer. Also, you will receive a link to this recording in your email that will most likely come to your inbox tomorrow, so look out for that. So I just want to say thanks everyone for joining and have a great rest of your day.
Thanks everybody. Have a great day.